Hello, my name is Igor and welcome to my Tech Fun. And it is a 3D printer review again, but this time a little bit special, at least for me. And what I have here is the Super Racer from FLSUN company. And this box is sent to me by FLSUN for the review. This is a delta printer. This means its moving mechanism is a little bit different. And I believe that this type of the mechanism has the biggest potential to be fast. As you can see, it is advertised. It's even on the box. To understand, let's compare it with the different mechanisms. What I have here is the cubic frame cartasian, and this is under 5, and that's a CoreXY printer, that's under 7, only I opened the box so I can show you inside the movement. Cubic frame cartasian, under 5. Different stepper motor for each coordinate movement. For example, this stepper motor moves the head in y-axis. This stepper motor moves the head in x-axis. And if we want to have the diagonal movement, of course, in this case, two stepper motors has to work together. This means we can get higher speed if we have a diagonal movement compared to the linear motion. But the biggest problem with this structure is this stepper motor here, because it is on moving part, so it must be light as possible to get a less moment of inertia in this movement. Now let's see the CoreXY. And what you see here is the CoreXY mechanism on Ender 7. Here we have two stepper motors which are responsible for the movement in X and Y direction. And if I rotate them together in same direction, then I have movement in X coordinate. If I rotate them in opposite directions but together, in that case I have movement in Y direction. So in this case the CoreXY mechanism has the advantage compared to the Ender 5 or cubic frame cartasians. But if I want to have diagonal movement, I'm rotating only one stepper motor. So if we are talking with diagonal movement, in that case the cubic frame cartasians would have the advantage compared to CoreXY. But the biggest advantage of CoreXY that these stepper motors are static, they are not moving, and they can be bigger, and they are on these two printers. But with the CoreXY, very important is this timing belt. It is much longer, so it must be very precise, very good tension, and usually it is wider compared to the cubic frame cartasians. So this timing belt is very important in this mechanism. And with delta printers, if we want to move the head in only one coordinate, even then all three stepper motors has to work together, and depend on the position, sometimes just a small movement on one stepper motor will result few millimeters on the build plate. That's why it is important with the delta printers that the motion to be very precise, and I hope they didn't use the V-slot wheels for the linear motion. And I'm not sure the movement is solved by the lead screw or timing belt. Let's see the specifications and then what's inside. The build plate is the diameter of 260 millimeters, and in Z-axis we have 330 millimeters. It is a Bowden style, but with this the extruder stepper motor is not on hot end, so it's fixed. In this case the moving part is lighter. The temperature, I found different sources, but probably it has that tube which touches the nozzle type of the hot end. So probably the maximum temperature is 240 on the nozzle and 100 degrees Celsius on the build plate. Now the speed is 150 millimeters per second printing speed, which may go up to 200 millimeters per second, different settings. And it has 32-bit board, silent stepper motor drivers, and also it has auto bed leveling sensor. Rest of the specifications you can see on the website, but now let's see what's in the box. It even has this protection foil on it. User manual. Nice detail. Oh, this will be very big printer. I believe these are those vertical alloy extrusions. And I can see a linear rail inside, and the motion is over the timing belt. Power cable. USB cable, some tools, cutter, bolts, and probably a spare hot end spatula for removing the object, parts for the spool holder, and these are those arms properly which holds the hot end. Oh, they are very light, so probably they are really from carbon or something like that. Beautiful piece. This is the top of the printer with the electronics inside. Oh, a display. This is the base of the printer. There is the switch 230 or 150. I can see the switches on 230. In my case, that's okay. I can see some SD card reader, Bowden tube, grease. This is the moving part, the hot end, and it has very nice cooling. You can see two fans for the part cooling. Cooling is from two sides. Sample filament, not much, but it arrives on the spool. I appreciate this because it is very dangerous when I just give you some, I don't know, some filaments without spool. It can fall down easily from the spool holder. So that's a good solution. I'm not sure what is this for. Now I believe that this is the this is an extruder with a stepper motor. It's Bowden style, and there we have a filament runout sensor too. And the last thing, I'm not quite sure, maybe this is the auto bed leveling sensor, but I'm not sure at this moment yet. And the box is empty. I always like to start with the part list to check if everything is included, but now I will do it off camera. And now let's start the assembling. In first step I have to place this top shell upside down, and I have to mount these axes, and they are labeled. For example, you can see here a Y, and if I take out the cable for the stepper motor, it said also Y. Of course, XYZ, these are not real XYZ coordinates in the printing, they are just labels for these axes. Pay attention not to damage the screen during this process. Connecting the motor cable. And I have to use these longer bolts. So always tie the bolts diagonally. And I have to do it with the other two axes, only don't forget to plug the cable into the stepper motor before you mount the axis. The printer is still upside down, but now I mount the bottom side, which goes on the top, and the logo shows you the front part, so this has to be on the same side. And this shell should be inserted here into these guide rails. And now, using again these longer bolts, I have to mount the alloy extrusion to the base. And again, it is very important to tie these bolts diagonally. And I have to repeat this with the other two axes. It's still upside down. This is the front side of the printer, and I have to slide this display holder. And somewhere when it is on a lower third, I can rotate this to lock it in a position. And now it's time to rotate the printer in normal position. And now I'm starting with installation of these arms, and I can see they're not labeled, and there is no up or down side. They are connected with these springs, so all I have to do is to somehow place them on these balls. Ah, it's finished. And same with the other two axes. And now the installation of the, I think it's called effector or the hot end, and this logo must be on the front side. And now I can show you a little bit how this delta moves. So if I move only one axis, this is rotating this way. So actually, if it has to move only in one axis horizontally, in that case all three stepper motors has to work together. Of course, with G-codes we are sending just the position of the nozzle, and all calculation will be done with the firmware on the mainboard. We have the tool holder. It's time to do some wiring, and there is the main cable on the top. I will not remove this zip tie, maybe it's better if they are connected. Now I have to connect these wires, and the color must be matched. There we have two black colors, but probably they are from the fans, so they are equal. And there is one more, it says level on it, so maybe that's the leveling sensor, which is removable. Ah, it's magnetic, we will see later. And now installing the main cable connector up. There is a groove, so it has to be placed on correct position. And I can secure it with this nut. And I have to place this cable into this groove. And now mounting the extruder and the filament runout sensor. So we have these small hooks which goes here. And I have to secure the position with these smaller bolts. I'm installing the cable on the filament runout sensor. And also on the stepper motor. And now I have to insert this Bowden tube into the extruder and pull this ring down and secure it with this buckle. And I have to tie the Teflon tube and this cable together. It's a little bit hard to see on the picture, but it should be somewhere here above these joints. Next is preparing the spool holder using these two bolts. This looks quite small. Of course it will hold this kind of spool. This is regular size of the spool, but I have several these types. These are Prusa spools, and yes, maybe 70 millimeters wide spool can fit on this, and definitely I can see what will be one of my first upgrades, which this printer will print for itself, some kind of new spool holder. Here are two holes, so the spool holder goes here on the top, because filament will go down through this hole. I have to move a little bit this bed. Okay, now it's coming down. It has the textured glass on the top surface, so the specification of it is that the object sticks good to the surface, and when it's cooled down it should be easier to remove it. Now we will see. This is the right side of the printer, and check one more time if this switch is on the correct voltage for your country. And now I'm ready to plug the power cable. This is the left side of the printer. And let's turn it on for the first time. Wow, great animation. And the system is ready. I really like this screen. It's magnetic and you can hold it in your hand. And usually I always check if the movement of the axis is correct, but I'm not sure will it work now with the delta already. Ah, very nice responsive screen. Move. Oh, that's 10 millimeters. It's working. Very responsive screen. I think this is the best touch screen so far I tested on CD printers. And now let's start the auto leveling process. You don't have to do the whole process every time before every print, because part of the data, the mesh offset, will be stored in EEPROM, because this bed is fixed. There are no springs or similar, so it will not move. First step is to check is there any plastic on the nozzle. If there is, then remove it with the pliers. And then I have to mount this sensor. It's magnetic, so this touching probe goes approximately above the nozzle, below the nozzle. And I have to connect the cable. Tools, auto level, auto level. Please plug the leveling switch before auto leveling, so I already did that. Yes. After approximately 2 minutes the leveling is finished. Now I have to remove this sensor. And move to Z0. Please remove the leveling switch before moving to 0. Yes, I already did that. Next step is to place some paper sheet below the nozzle, because it stops approximately 2 or 3 millimeters above the build plate. And now I go to the adjust Z. And I have to go up and down. These are those baby steps to get that perfect friction between the bed and the nozzle. And when I finish, I click save. And I can come back to the home page. Super Racer, you can see the printing size, firmware Marlin 2.0.8. Next step would be load the filament and print something for SD card. But unfortunately my SD card arrived broken, so I'm not sure what's on it. And also I would like to talk about this card reader. Very interesting. The card goes here from the front. And it goes here on the top, so this is the hole for the USB cable, this is the USB disk, and for SD card. Inside user manual was this update content. Here we have the picture of the mainboard and some additional instructions. For example, how to format SD card, and it says it's not good to have too many files on SD card because it will slow down the reading of the G code. And another important information, how to switch to U-disk printing, because this printer can be switched only in one mode, or reading from the SD card by default, or if you update the firmware, in that case you can switch to U-disk printing. Since I don't have the content of the SD card, but on Reddit I found the Cura settings, and there are the 4.10 settings too, which I currently use. These are those files I need, and there is the readme.txt file which holds the instructions. All I have to do is to copy these files into Cura installation folder into proper place, and then add new printer, not network printer, and search for the FLSUN in this list, and there will be the Speed Racer included in this list, and I have to add this printer. and after a few moments the printer will be added into Ultimator Cura. And I will insert the first STL file, which will be the calibration cube, slice it, and then I have to copy the G code to the SD card, and it's ready for printing. It's time to preheat the nozzle and insert the filament. Tools, heat, and there is PLA. 220 degrees Celsius preheat, default temperature, maybe it's too much a little bit. 210, okay. Cut the end under 45-degree angle. And then through the hole and the filament runout sensor into the extruder. And now let's insert the SD card. Print calibration cube. During the printing I can see the temperature of the nozzle and the bed, the percentage, printing time, and here I can see the speed and the current z-axis. So two very interesting and useful informations to me, especially the current z-axis, because from this I know how much I have from the printing. And we can pause the printing or cancel properly to stop the printing. We can fine adjust the z offset if we didn't do that earlier. And operation, well, here I can change the temperature, the fan speed and the printing speed. And now let's see the time lapse of this cube, but it's almost 1/4 is finished. This was really fast, it was printed in 12 minutes. A very interesting cube, and actually it was printed in 12 minutes. So I never printed this calibration cube so quickly. I can see this elephant foot, so this means I have to raise a little bit the Z offset, but otherwise quality of this surface is quite good. I'm not even sure does it make any sense to measure it, but let's do it. Yes, I definitely have to raise the Z offset. This is quite good, and this is also acceptable. It's slowed down now because in Cura it was set that to slow down when there is a minimum layer time below, I don't know, 10 or 15 seconds. But at least this final chimney will be also nicely printed. And it's finished in 36 minutes. So this was 36 minutes Benchy, and this was even slowed down because of that minimum layer printing time here on the top. So at least it came out good, and I really cannot see big problems with it. Here I can see one horizontal line and a little bit more ghosting here. I'm not sure it'll be visible. But otherwise no stringing at all. Well, unfortunately the 60mm retraction is very loud, but at least we have no stringing. The bridging came out perfectly, the chimney, the overhang also, so I'm very happy so far with this printer. And it's so quiet, and the loudest thing is actually the extruder and the retraction. I'm not sure, it looks like it doesn't have the silent stepper motor driver on the extruder. Definitely this spool holder will be replaced very quickly. Now my plan was for next printing to print exactly this object. This was printed on my Ender 7, the CoreXY printer, but unfortunately this cannot fit on this build plate. So I cannot compare directly. Maybe in separate video this will be my topic to compare with some same objects printed on both printers. But instead I will print these rolling dice because I need two cylindrical parts, and one will be printed on my Prusa Mark III's, and now the other will be printed on FLSUN Speed Racer, and I want to compare the printing times. This is the first cylinder on that dice, and it will be printed in approximately 2.5 hours. Printing is finished in exactly 2 hours and 30 minutes. And one of the first problems I met is that I cannot use the same spool like I printed with the Prusa, because it cannot fit on this spool holder. So I have to use, this is very similar color but not same, and at least this one can fit on this spool holder. Oh, it was finished too early, I wasn't here, in 1 hour and 7 minutes. Cura told me that it will be 1.5 hours. This was the support. These objects have different color because originally I wanted to use this color, but this spool cannot fit on that spool holder on FLSUN, so there I have to use this color here. So there is small difference in the color, but in the quality actually I cannot see any difference. So this one was printed in a little bit more than 1 hour on FLSUN, and this one was printed in 2.5 hours on Prusa printer. And now let's put this together. Actually, on the daylight I noticed that the Prusa cylinder dice is smoother a little bit, but the dimensional accuracy was equal. And definitely 2.5 times longer printing time, definitely it will be a deal breaker in a lot of cases. And now the conclusions. Well, it was a really refreshment to test a little bit different printers like those cartasian styles, and I really enjoyed this review. And I will start with I really like with this printer. Of course, my favorite was this delta mechanism, and it really gives the picture that it is good quality printer. For example, these carbon fiber arms or linear rails, and my favorite is this touch display. Not only this is movable, but it is the best touch display I tested so far on all printers I have here. And I think the FLSUN could make a small fortune if they could sell this display for different printers, like for, I don't know, either 3V2 or something like that. Now there are few space for the improvements. What I didn't like, the spool holders, but only this arm has to be replaced, and probably after I finish this review I will design a new one if there is not on Tigers already. And then next one is that noise from the retraction. During the extruding I cannot hear that noise, but of course that's slower, but during the retraction that's quite annoying, and that's the only reason why this printer will not be moved into my office, because I'm looking for a secondary printer which will be actually behind me 1 meters only, and that retraction is quite annoying. I'm not sure, is this a different stepper motor driver or it's too fast? I'm not sure at the moment. The next one is this Bowden tube, which could be, I don't know, I think they could use some Capricorn turbo or something like that, because it is more precise, and we could go a little bit above those 240 degrees Celsius. I already prepared the replacement, but I will leave this one for now. I want to see how it works. And now let's talk about this extruder. It is some kind of Bondtech clone or something like that, but I think the tension, it is too many plastic parts, and I think the pressure on the filament is too big. I know because I can see a mark from the gears. Probably you cannot see it, but you can hear it. One of the main problems is that this spring is too short. When there are no filament inside, there is almost minimal pressure here, but when a filament is inside, the pressure is too big, and I cannot reduce it because this bolt is too short. Probably I will replace this spring with this one. This is from Ender 3, the spring which I replaced with those yellow springs. Only I need a little bit longer bolt, just with a hexagonal head M3 bolt, and I will print some kind of knob head at the end, and I will try with that one, because this pressure is too strong, which is currently on this filament. And I hope with this solution that tick sound I can hear from time to time will also disappear, because for testing I tried to hold it with my finger, and it was much better. If you have some additional experience or opinion about this extruder, please write me in a comment. And I will play a little bit more with this printer, and then I want to do some kind of side-by-side comparison with my Ender 7 to see which is faster. And I hope you will follow me to that video too. Until then, thank you for watching and happy printing!